Returning to slide 99, which is the slide we ended on in segment 19, we consider three different models for the influence on the distal outcome. The first model has a C1-C2 interaction, and that's the model that's shown in the picture up here. C1 and C2 influences the distal outcome site 4, and their interaction is marked by that broken arrow. Model 2, only C2 influences the distal outcome. In Model 3, we have C1 and C2 main effects, but not the interaction effect. Now, this is for regular LTA, but you could consider this also for random intercept LTA, where you have a random intercept factor up here influencing the items at the 2 time points. And in that case, the poverty covariate may well influence F, the random intercept factor as we've seen, and the random intercept factor may also influence the distal outcome. The C1-C2 influence on site 4, however, remains the same. That's not part of the measurement model. Yeah, and you can also consider a multi-step procedure where in the first step you do not include the distal outcome, just to ensure that the solution that you get by analyzing this part stays the same when you add the distal outcome. With this binary item, nothing changed in that regard, hardly at all. But it could be the case that it changes if you have, say, a continuous non-normal distal outcome. So here it is. RI-LTA version is possible. I don't have much experience with that at all yet, but I think it should work all right. And then the multi-step approach here. So now let's take a look at the outputs for these 3 models, which is outputs 14, 15, and 16. Actually, we don't have to look at model 1's output 14 because that has already been described on slides 96 to 97. So let's go straight to model 2, which is output 15. So model 2 is the C2 only approach. How do we do that? Here you have it. The input instructions then are, again, using the dot approach. So you have C1 number 1 dot C2 number 1. And the only thing that changes here is how we deal with the thresholds for the distal outcome. So they change over the C2 classes, which is what we wanted. But when we change from C1-1 to C1-2, we repeat the labels that we have at the top here. T11, T12, T13 repeats T11, T12, T13. And for C1 class 3, same thing, T11, T12, T13. So that shows the flexibility of working within the dot approach in that framework. We just can change the equality structure. Now let's take a look at model 3, which is a little bit more complex. The input instructions once again use the dot approach, and here we actually stay with the original 9 thresholds: 11, 12, 13, 21, 22, 23, 31, 32, 33. So 9 thresholds corresponding to each cell in the 3x3 transition table between C1 and C2. But we add a model constraint section here. So we're going to put constraints on these 9 thresholds and express them in terms of fewer parameters, which represent a main effect model. So here are the parameters. A is going to be an intercept, B's and C's are going to be slopes. So the way to think about this is that C1 and C2 give rise to dummy variables. C1 has 3 classes, so we have 2 dummy variables that represent that. and that will be the two slopes for those two dummy variables, b2 and b3. C2 also gives rise to two dummy variables, and those slopes will be called C2 and C3. So this is essentially dummy variable regression. So we have then an intercept instead of a threshold. So we call that A. It doesn't matter which of these cells you actually call A. So then when you go from, you stay on the first row, when you go from column 1 to column 2, you add C2 from the C2 class variable. And then you go to the third column, you add C3. And then you go to the second row, that is class 2 for C1. Then you add B2. And for T22, you keep the same, in the same row, B2, but you add C2. And then for the third column in the second row, you add C3. And then you go to the third row of the C1, C2 table, and you add B3. Third row, second column, you add also C2. And for the third last column, you add C3. So those are 5 parameters that you express the 9 thresholds in. So in the model estimation, we're actually not estimating 9 parameters, but estimating these 5 parameters. And you find them in the model results section. So we look at model results here, and then we have the section new additional parameters A, B2, B3, C2, C3. Some of them went big and therefore were fixed. It doesn't matter which high value you fix it at really, but it corresponds to 0 cells, which we're going to discuss further in the error message section. So there you have the values, and that's how we got to the results with 33 parameters and this likelihood value. Now, just from a pedagogical point of view, it could be of interest to try to figure out what an incorrect approach would be. So we want to have a main effect model here. We want to have an effect from C1 and from C2. So why don't we just simply abandon the dot approach and go into the usual model C1, model C2, and mention the site threshold for C1, have it change as a function of C1 classes, and also change as a function of C2 classes rather. Well, it's tempting, and I've actually made this mistake myself, but what this means, the parameters that you mentioned in model C1 are held equal or not changing over the C2 classes. They're supposed to change only over the C1 classes. Likewise, here, parameters I mentioned in the C2 classes are assumed to be equal across the C1 classes. So there's a contradiction here. So we have to remember why this model C1 and model C2 construction was set up in the first place. It is to say at time point 1, here are the parameters that change, and they don't change across time point 2. Time point 2, here are the parameters that change across latent class variable 2's different classes, but not across the classes of C1. That's the standard setup. You could, of course, imagine that C2 thresholds were influenced not only by C2 classes, but also by C1 classes. But then you would not use this construction of model C1 and model C2, which is a simplification. So you don't have to use a more complex dot command that you would otherwise have to use. So this is the wrong approach to take, and it gives the wrong number of parameters. So you will find out that it's not the right way to go.